another. Okay, so we were talking about ball bearings, right? Now, in ball bearings, as I said, that there are different types of ball bearings. But before going there, let's see. Uh, we have to know about the loads that are that a shaft or a bearing is subjected to. Let's just take a simple shaft. ठीक है जी? और let's say that we have a shaft uh, over here. ठीक है जी? And let's put uh, two bearings on this shaft. For example, let's say there is one bearing over here and there is another bearing over here. ठीक है जी? Now, what can be the loads on this shaft? The first thing is that let's say that this is the axis of rotation. ठीक है जी? Yeah, the axis of the shaft. ठीक है जी? So along the axis of the shaft, ये जो axis है, there can be forces that are acting along the axis of the shaft. ठीक है जी? What will we call these forces? And the forces that are acting along the
Longitudinal, sir.
Normal.
Longitudinal.
Normal.
जी
Longitudinal. Longitudinal forces, sir.
अच्छा,
normal forces.
कोई और नाम हम देते हैं इसको? ये देखें, this is the axis of the
Axial.
shaft. अच्छा, axial.
sir,
Axial would be a better name. ठीक है जी? So there can be axial load. ठीक है जी? और इसको हम एक और नाम भी कहते हैं, that is thrust load, right? So the load that is acting along the axis of the shaft, yeah, that the bearing is taking, so along the axis of the shaft, उसको हम axial load या thrust load कहते हैं, right? Now, we can have another load which would be perpendicular to the axis of rotation of the shaft. ठीक है जी? Or that is acting towards the center of this shaft, yeah, toward that is along the radius of this bearing. तो इस load को हम क्या कहेंगे? We will call this
Radial load.
radial load. ठीक है जी? तो these are the two loads that a bearing would take. ये radial load किसी तरफ से भी हो सकता है, not only from the top, but it can be from anywhere. ठीक है जी? तो therefore we have these two loads that the bearing has to counter. Now, if we look over here, there are different types of bearings over here. For example, this deep groove bearing, ball bearing, the deep groove ball bearing, इसी तरह filling notch, angular contact, self-aligning, double row, and so on. ठीक है जी? I'll just talk about one or two of these, and I have already uploaded an assignment which you have to do and state the uses of these or the distinct characteristics of all these bearings. For example, this deep groove bearing can take radial load as well as axial load. यहाँ पे अगर आप देखें तो in angular contact bearing the contact is a little bit different, and the contact is such that the force is applied in not only here on these points बल्कि it is applied at some angle ये, ठीक है जी. So that is why it is known as angular contact bearing, and again it can take some radial load and axial load. But this would be your assignment to come up with the uses of all these bearings. I'll just let you know that in ball bearings, if you look at the contact, the contact in a ball bearing would be, let's say, if I have a sphere and I have a line in here, what will be the contact between the sphere and the line? कौन सा किस किस्म का contact होगा?
Tangent.
Tangential, and that would be only k since it is tangential, so only a point of the sphere is going to touch this surface. ऐसे होगा ना, ठीक है जी. So only this sphere is only going to touch at a point. दोनों सर जहाँ पे भी इस surface के साथ if it has contact, so it is going to be a point contact. Remember this. So if we are using a ball bearing, then the contact is a point contact, right? Now, we also talked about roller bearings. So roller bearings are bearings which have um, uh, rollers instead of balls. For example, if we look at this picture, तो यहाँ पे आप देखें, these the balls in there, they are replaced by these rollers now. And again, there are different types of rollers in here. This is a straight cylindrical bearing. If you look at the contact, since it's a roller, so the contact between these two surfaces and the roller is a line contact. ठीक है जी. तो we talked about point contact in ball bearings, and we have a line contact in roller bearings, right? So what do you think, which bearing can take more load?
Roller
Ball
bearing, sir.
bearing.
Roller bearing can take
Rollers.
more load because the contact over here is more, or वहाँ पे the load is concentrated on a point. Now again, there are different types of roller bearings, and they all have distinct properties. For example, this one, this straight roller bearing or cylindrical roller bearing, this can only take radial load but not axial load, not as much axial load. This one is um, a spherical roller bearing. This one can take thrust load as well as radial load. But I leave this on you. I've already given this as an assignment to you. Now, so the main thing is if we look over here, so uh, just note that bearings are standard. ठीक है जी. Bearings are, there are different bearing manufacturers, and they manufacture these bearings in in standards. ठीक है जी. Now let's define some terms over here for bearings. Now, um, whenever we need a bearing, we basically go ahead and design a bearing, and basically we select a bearing from the available bearings in that a manufacturer would give us, right? So if we are talking about a bearing, so there are certain parameters, there are certain definitions that we need to know. For example, the life of a bearing, right? So what would be the life of a bearing? The life of a bearing is the number of revolutions, uh, or it will be, it can also be given in hours, right? So if we are talking about the life of a bearing, so how many The revolutions can a bearing safely complete until it fails. So that will be uh, the life of a bearing in revolutions. If we are talking about hours at a given speed, so it will be the number of hours at a given speed that that a bearing can complete without failure, right? So let's say, how do we define failure, or how do we define life for a bearing? There are different terms that we use. For example, life rating, rating life. Now, what is rating life? Life required for 10% of sample to fail. For example, you have a group of bearing, and from that group of bearing, if 10% of the bearing fails, you call that the rating life, and we represent that by L10, and this is known as the minimum life of bearing. ठीक है जी. इसी तरह median life is the life, it is the average life of a bearing, which is for 50% of the sample to fail. And basically in this, when you measure median life or the average life, you take many groups of bearings, and for those you can find out the median life, right? This median life is about 4 to 5 times of this L10, because over here you only need to have 10% of the sample fail, but over here it is 50% of the sample that would fail. ठीक है जी. So for example, you took 100 bearings, so when the first 10 bearings fail, and whatever revolutions those bearings gave you completed, you would say that that is the L10, or that is the rating life of that bearing. ठीक है जी. So this is a very important term that we use when we are talking about the life of a bearing. ठीक है जी. Now, the next thing is okay, we also talked about um, the load. ठीक है जी. So um, there are some terms that we need to define about load, and that is कि हमारे पास we have catalog load rating. Now, what is catalog load rating? Catalog load rating is the it is represented by C10, and as we just defined, okay, if you take bearings and the 10% of those bearings fail, so you call that life the L10 life. ठीक है जी. Now, um, if I have to be more specific, a bearing will only fail if it has some load on it. ठीक है जी. So a group of bearing, ठीक है जी, it's the constant radial load that causes the 10% of the group of bearings fail. तो ये जो L10 आपको मिला है ना, आई एम श्योर दैट इट इज एट सम लोड. ठीक है जी. इट इज एट सम रेडियल लोड. तो उस रेडियल लोड को हम क्या कहेंगे? व्हाट विल वी कॉल दैट? वी विल कॉल दैट C10. ठीक है जी. तो there is some load basically that is causing the 10% of those bearings to fail, और उसको हम क्या कहते हैं? We call that load C10, या we call that catalog load rating. And again, it depends on the type of the bearing, the geometry, the accuracy of fabrication, and the material of the bearing. अच्छा, we also call this C10 the basic dynamic load rating, or the basic dynamic capacity of the bearing. ठीक है जी. There is another term that we use that is known as the basic load rating. What is the basic load rating? That is denoted by C, and a catalog load rating based on the rating life of 10 to the 6 revolutions of the inner ring. Now, what is this 10 to the 6 revolution? Generally, this is a standard. ठीक है जी. When manufacturer talk about the revolutions. So they set up a standard revolutions, which is, let's say, the 10 to the 6 revolutions. So any load rating that would give us the 10 to the 6 revolutions of a bearing life, we will call that the basic load rating. ठीक है जी. The radial load that would be necessary to cause this failure as such a low life is unnecessarily high. ठीक है जी. जाहिर है, the basic load rating is a reference value, not an actual load that you would look at. Why? Because when we use bearings, so when we use bearings, we have our own conditions, we have our own requirement of the load that the bearing should take. ठीक है जी. Any question? Any
सर अगर मैं
question?
100 बेरिंग्स इंस्टॉल कर रहा हूँ सर, तो सबका लाइफ टाइम तो सेम होगा ना सर? तो 100 के 100 इकट्ठे अगर फेल हो जाए?
अच्छा, इस तरह है ना कि हम इंस्टॉलेशन की बात नहीं कर रहे हैं यहाँ पे. बेसिकली what we are saying here कि when you are designing a bearing, तो basically होता क्या है कि एक तो ये बात कि 100 bearings will never ever fail at the same time. ठीक है जी. This will be a very मतलब
सर उनमें लोड डिस्ट्रीब्यूशन क्या डिफरेंट होती है इस वजह से?
नहीं, दिस विल बी अ वेरी अजीब इत्तेफाक. ठीक है जी. आप if if there is a certain cause that can cause all the bearings to fail at the same time, लेकिन as far as bearings are concerned, तो वो एक वक्त पे 100 bearings fail नहीं हो सकते. What we mean to say here is कि bearing की जब हम life determine करते हैं ना, तो हम ऐसे determine करते हैं कि हम 10% bearings जब fail होते हैं ना, तो we call that the catalog load rating. For example, manufacturer जब आपको bearings provide करेगा, तो he would have performed these experiments. उसने एक group of bearings लिए होंगे और उसने उन bearings पे ये experimentation would have been carried out, and on the first 10%, the first 10 bearings that fail, let's say you installed 100 bearings and then started counting you started operation and you counted the number of revolutions, and one bearing fails, then another bearing fails, or let's say two bearings failed, then up to 10 bearings, then you stop there and count the number of revolutions that it would take, and that load that caused that failure. So that is your L10 and that is your C10. समझ आ गई बात की?
सर हम इंडिविजुअल वैसे ही परफॉर्म नहीं कर सकते एक एक बेरिंग पे कि उसके
क्यों
अगर
नहीं कर
10% ऑफ रेवोल्यूशन अगर हो जाए तो
बिल्कुल
हम?
कर सकते हैं, एंड दैट वुड बी जस्ट फॉर वन बियरिंग. ठीक है जी. दैट वुड बी जस्ट फॉर वन बियरिंग. और अगर आप पिछले स्लाइड में देखें तो हमने यहाँ पे इट इज ऑलरेडी डिफाइंड कि लाइफ को हम कैसे डिफाइन करते हैं, नंबर ऑफ रिवोल्यूशन. एक बियरिंग को आप ले लेते हैं तो यू जस्ट इंस्टॉल दैट, एंड इफ इट फेल्स, whatever number of revolutions that bearing completes, that is the life of that bearing. लेकिन देखें, when we talk about parts, basically हम prediction करते हैं कि इसकी life कितनी होगी. um, when you are designing a bearing, you are just predicting कि अगर इस bearing पे मैं इतना load apply करूंगा तो it is going to give me this many revolutions, right? So
ओके
individual
सर.
bearing के लिए तो it is very easy. You just take a bearing and install it and just keep running it. When it fails, that is the life of that bearing. समझ आ गई बात?
ओके सर.
ठीक है जी. तो now
सर वो 10% में जो बेरिंग्स फेल हुए हैं, तो
yes,
उसमें तो सिर्फ सबसे कम वाला हम लेंगे ना सर, उसको डिजाइन करेंगे ना?
no, the first 10 जो फेल हो गए, अभी देखें 90 of your bearings are still working. ठीक है जी. So this is the way we design bearings. If we say that the first 10 failed, so we call that the rating life. ठीक है, दिस इज
तो
स्टैंडर्ड.
10% का तो खतरा है ना सर?
yes, and those 10% will fail. देखें, it is almost equivalent to if you buy any product, anything, right? There are chances that when you bring something, right, to your home, let's say bulb, you bought a bulb. Now, what are the chances that when you install that bulb will not work if you buy a new bulb? What are the
कुछ
chances?
कुछ हो सकता है सर.
Yes, sometimes it can. ठीक है जी. लेकिन that means कि if that happens, there is something wrong with that bulb. ठीक है जी. तो most of the time देखें, इसलिए अगर आप देखें, let's say if we take the example of your class या fourth semester में, अगर if we take that example, how many people can get A grade? कितने लोग A grade ले सकते हैं?
15% का.
चलिए 15%, ठीक है जी. तो probably this many, if we are measuring, if this is the number of students, ठीक है जी.
सर तो हम बस डायरेक्ट वो सबसे पहला जो फेल हुआ है सबसे कम लोड पे, तो उसके लिए डिजाइन क्यों नहीं करते कि बस खतरा ही ना हो?
अच्छा, तो मैं यही बता रहा हूँ ना. ठीक है जी. लेट्स से कि ये आपके जो हैं इतने लोग ए ग्रेड लेंगे, राइट? ठीक है जी. अच्छा, आपकी क्लास में फेल कितने होंगे? हाउ मेनी पीपल आर गोइंग टू फेल?
10% तकरीबन या 20.
चुरलट, probably these many would fail, right? Acha. Now you tell me, why don't we say that anyone beyond this is fail? हम ऐसे कर सकते हैं. Do we do this in normal life?
No, sir.
जो आप कह रहे हैं
No, sir.
कि the first one, who does not get A, that is not fail. Basically, the whole class, there is some distribution. These will get A, some will, more of them will get A minus, then B plus, then B. So many, or the average class is going to be over here around C, B and C. ठीक है जी. And then little of them D, and then some will fail. तो देखिए, this is normal. यहाँ पे आप देखें तो इसको हम नॉर्मल डिस्ट्रीब्यूशन कहते हैं. And it can go this way, it can flatten a little bit, it can be skewed to one towards, we can have a class where probably it will happen like this, right? More people will fail, but we are not going to decide over these. देखें, अगर आप, if you decide on the first bearing that fails, probably you are adding a lot of cost in there. ठीक है जी. तो this is just a standard कि life radian जब हम करते हैं तो we take the first 10% of the bearings that would fail. Otherwise, if you reject all now, that is going to be a problem, you know. ठीक है जी. तो generally, it's not going to be um, the representative of the whole group of bearing. ठीक है जी. अच्छा, इसी तरह यहाँ पे so now we know कि हमारे पास दो किस्म के चीजें हमने डिफाइन की, and that was, one was क्या? L10. ठीक है जी. And the other one was, the other one is, please help me,
C10.
C10. ठीक है जी. तो ये दो चीजें हैं हमारे पास. ठीक है जी. वन इज द लाइफ एंड द अदर वन इज द लोड. ठीक है जी. अच्छा, एक और भी लोड हम डिफाइन करते हैं, दैट इज द स्टैटिक लोड रेटिंग। और स्टैटिक लोड रेटिंग है कि इट इज द स्टैटिक लोड which corresponds to a permanent deformation of rolling element. And then we have also given this, the stressed contact area, which contact of 0.001 d. Again, uh, d is the diameter of the roller, and it is used to check the permanent deformation. Anyways, so now there is another term that we define, and that is the equivalent radial load. देखिए, we defined two types of loads. One was radial load, ठीक है जी, एक क्या था, radial load, and the other one was thrust load. Yeah, it was thrust load
Axial.
or
Axial.
axial load, right? So we can take both of these loads and we can express the combination of these loads as equivalent load. ठीक है जी, और we call that FE, हम उसको कहते हैं equivalent radial load. So not just equivalent load, बल्कि equivalent radial load. So how do we do that? Okay, हमने क्या किया कि we combined radial load and thrust load, and we call that the equivalent radial load FE. Now, a constant stationary load applied to a bearing with rotating inner ring, which gives the same life as the actual load and rotation conditions. ठीक है जी, तो that will be the equivalent radial load. Now, let's see. अब देखिए, now does this make sense? Let me pose a question. ठीक है जी, and my question is कि let's say my question for you guys is कि हमारे पास we have a bearing, right? We have a bearing. ठीक है जी, we defined two things. One was load and the other one was life. ठीक है जी, अच्छा, so let me ask you, if I have very heavy load, right, what will happen to the life of a bearing?
Decreased.
It will be less. ठीक है जी, what if I decrease the load? What will happen to the life?
Life will increase.
Life will increase. So this means that whatever load is involved or a bearing is subjected to, that would define the life of a bearing. ठीक है जी, so nominally identical groups of bearings are tested to life failure criteria at different loads. ठीक है जी, और उस different loads से अगर आप देखें तो if we plot the log of the load, ठीक है जी, this is log of the load. Let me do this. ठीक है जी, this is log of the load that a bearing is subjected to, and this is log of the life or the revolutions that a bearing would give. ठीक है जी, and if you perform experiments, it is going to give us this kind of behavior. If we fit a curve over here, so that curve would be this curve, ये हमें देगा. इसके लिए अगर हम if you look at this curve, isn't this a straight line? A straight line है ना?
Yes, sir.
Yes, sir.
Right? So, and but the scale over here is a log scale. ठीक है जी? For a log scale, the equation of straight line is this